Good afternoon, everyone. My name is Bo Guo, and it's my privilege to speak this afternoon. And I just had my stomach filled, half filled, feel contented. And myself, my left brain had been fried because of this morning's intense session. The only capacity I have left is on my right brain. So instead of quite intense technical session, I'm going to tell stories with a cultural twist. However, at the end of my presentation, there will be a language test, language quiz. So pay attention. Well, what language? Because I think it's not fair that we all have to speak English. So I'm going to play some Chinese characters. So pay attention to see how many of you get it at the end. All right. Can you hear me? Correct. Okay.
You can use this one.
Oh, okay. Well, apparently, theodolites to AI, theodolites not way back in the ancient times. So give some perspective. I'd like to just have one slide, talk about, oops, I guess I did one too many. How do I go back? No. This is second slide. No, actually, I have my second slide. Yeah. Oh. Was accidentally, how do I?
隐藏，你要展示。
隐藏。
我来。
Okay, sorry about that. So, yeah, now we'll go. Okay. All right. So let's talk a brief history because I think it's relevant because quite a few of you are coming from different culture, different parts of the world. So looking at this timeline and dating back, 1,000 years old. So in the Zhou dynasty, look at the land ownership. At the time, land was owned by lords, not by individuals, right? And at the moment, there's a Gogu theorem. You might not know Gogu theorem, what that is. It is, in fact, Pythagorean theorem. Okay, so by then, that's actually predating Pythagorean, the time that was done. Certainly used rope and compasses. At that moment, we had it with water level. So that was quite sophisticated thinking about over 3,000 years old, okay? And then, certainly, the first emperor, Qin, and he, among many other great achievements, they unified the measurement system for such a big country, at that time called Qin Empire. Then, significantly, I think during the Han and Tang dynasty, there's actually 6 principles of cartography. So mapping, not only you just measure it, because the measurement, the ultimate goal for measurement is to present them on paper so people can visualize. Essentially, we're talking about vector mapping, right? So at that moment, we actually had it, okay? And there was also grid-based systems, mapping, what have you. And in Song Dynasty, we're talking about 12, how many? Yeah, 1,200 years ago, there's actually a fish scale registers. It is fish scale register, essentially official register showing the location, showing the map, the size and everything, the compass and surveying. And that's during the heyday of Chinese dynasty, Ming dynasty, when Zheng He, heralded with thousands of ships, making 7 trips across the world through the ocean. Then came the Qing dynasty, which is the last dynasty, China, and the Western influence came into China. So it's kind of, China is no longer close to the rest of the world because during the Ming dynasty, 1 year, the Qing Emperor Wanli decided, China is so big, so self-sustainable economically, we don't need to deal with foreigners. So that was actually the moment Chinese power declined. Okay, and this is a little bit ancient history as a background to where we are. Okay. All right. Oops, what's next? Okay, here we are. So talking about transformation, I think 30 years, and I'm excluding mostly from, the demise of Qing dynasty till the kind of Deng Xiaoping's era, like the open up and reform. So China witnessed in a short time span from analog, digital, informatized, if you agree it's a word. In fact, you might be able to locate it in your dictionary, and intelligent. So we'll talk about this transform and that transformation and three of them. So what is analog? So in a nutshell, oops, why I keep on going back? When you go forward, that's where we should go. And so it's essentially continuous and physical. By continuous is unlike discrete, right? Continuous, scale versus discrete, which is digital. So it's chunked and virtual. And physical meaning you can touch it. The output, the authoritative version of output is a paper, touchable physically. And of course, in digital age, you can print out your digital kind of output, but it's still virtual. You can easily copy them, virtual being the original copy. So this is a digital, I think it's easier for us to relate. Then what is called informatized? Informatized, our understanding here is focus on organize and manage the data. This is no longer just I produce a paper, I give you a shape file or DGW file, I'm done. So that's an isolated piece of data, but we now want to organize them in a database or in databases. So all the information are intertwined, connected, and that become what we called one set of data, right? Yesterday, if you heard about yesterday, one set of data, one platform, and many scenarios, right? And then what is the intelligent way of doing serving and mapping? Oh gosh, I can never learn. AI, automation, or AI assisted. So that's our definition. So today we're going to go through this. So why we need to make this jump? Pay attention with some of Chinese characters. More, fast, good, and cheap. So say, hey, why you use cheap? Cheap usually means, it's not something like the old connotation of Chinese product being cheap and bad, right? But when you have good in front of it, good and cheap, that's good, right? Who doesn't want that? I think this actually 多快好省, very easy, right? 多快好省 is actually extracted from Chairman Mao's book. Yeah, and it is really, we are always pursue this goal. Want more, want faster, want better. We want that to be inexpensive and affordable. So that's the driver. Typically, of course, you can say human greed. Yeah, there you go. Capitalism, especially. But we stick with more positive tone. Okay. All right. So talking about analog, field of survey and mapping, it's blank. It is literally a blank. Why? Because that predates my time. because I do not know. Unfortunately, or fortunately, I did some research through where from DeepSeek yesterday. I said, I cannot go over there, just present a blank screen, even though this is outside kind of my time of 30 years. So I did some screen research. I give no, it's still screwed up. Sorry. Could you help a little bit? I'm missing something. Or maybe that isn't all that important. But anyway, China did have its own analog stage. That's during the 50s to 70s and maybe early 80s, if I will. So we're talking about using the analog airplane and analog photo for large-scale mapping production. And that was mostly based on Soviet bloc technology. Because at the time, China was embargoed by the Western blocs. And the only technology, international technology, foreign technology is coming through Russia. So anyhow, now here's the analog. I said field surveying and mapping. So there's always field survey and large-scale aerial survey. So field survey mapping, you see this gentleman? And this gentleman could have been me 40-some years ago, because I did do something like this when I was in college, okay? And yeah, and what type of equipment are we talking about? This is analog and theodolites, okay? And so we have theodolites, plane table, tape measure, manual book, and polyester film. And yeah, and for most of us, except those young people, and they possibly know about this, they even know what rubber is all about, right? Rubber eraser. And some youngsters, they don't even know what is rubber eraser. I've never seen one. So here the paper. Yeah. So these are the equipment and the processes of generating from field reality to a paper-based reality, right? So, and this is the final output. Output is totally analog. So now let's look at the digital field survey and mapping, what that would be. So yes, we're using total station. Many of the survey points are recorded right in the unit. And however, you still have to mark the locations using pencil, paper, because the total station gather the essential areas and major points. But in terms of attribution, you still have to do that. So this is a total station, join, and the processing of that, the output is actually, once you gather the field data, know the field data into the computer, the output could be DGNs and shapefiles, what have you. So this is a digital kind of field survey. So what about the large scale production of Bing? Okay. Oh, okay. Yeah, here we go. So analog photography. This is the one left blank. Because I mentioned here, this is the 50s to 70s. We did have that. It's just beyond my age. I could not even find any of the equipment because those are most likely available only in museums nowadays. So think about the transitional photogrammetry production. This is transitional. This is in between. So this is essentially the age we started here in China. It's more like in this age. We did have a digital camera at that time and started analyzing aerial triangulation, which is partially that. And look at this. This plotter, stereo plotter. And this one takes both analog photos and digital photos. And you see the binoculars here. Binoculars over here is you need to train your eyes to look into so that you can identify depths and do the digitizing to gather the Z values in order to do that. So it's quite manually intensive, even with that. So analytical stereo plotter, that's what that is. So this is still a transitional stage. Now look at the digital stage, and now you have this workstation, and you have the full digital photogrammetry. You have software that control that. You're no longer having to have the binoculars. Mostly, you don't have to do that, but some of which, and how it deals with the triangulation or getting the z values, because it has the points being connected, the same points with multiple shots. Then the camera angles, all those can be calculated to derive the z value. But the production still needs manual work in order to achieve it. So that's a stereoscopic mapping and field mapping for indoor procurement. So there's still quite substantive involvement of people. So now we talk about the digitization to informationization. So again, I think the explosion of data and size and formats is just not sustainable with the old existing methodology. And again, we need 多快好省 in order to achieve what we want to do. And people say at this stage, digital foundation with all the data being involved, with multi-source data involved, they need a faster and better and more sustainable method to derive that. So what we have is a more integrated data acquisition. So now we have can have aerial, including satellite. We have perhaps post-mounted, high-mounted camera. We certainly have drone or low altitude flying object, flying vehicles, and certainly LiDAR. And here we have multi-source sensory fusion, wide coverage of data, and real-time data collection, the whole 9 yards that we are more and more familiar now, because it's getting to our age now, so to speak, right? And let's look at first look at the point clouds. So this is a LiDAR, mobile LiDAR units driving around, ground LiDAR. So it has capacity based upon the color, because one camera, multiple camera perhaps processing it, turn the LiDAR points with different color, so we know the object better. Or we base it upon the intensity through the processing of a software. Or this is another view of panoramic, vector overlaying. I think the camera view with color and overlaying on the LiDAR data set. So this is essentially point cloud management with the software support. By the way, EPS is a part of our family here. And then the point cloud acquisition method, you have the variety of ways, and including this one, I think is backpack LiDAR scanner. So you can go to position, location with a certain angle to make this happen. So it's pretty convenient with variety of way to access the reality, to represent reality at the end. All right, then we have oblique photography. You're shooting multiple cameras, different angles. And this is where we set the stage for our downstream 3D scene extraction and also through AI. So this is a prerequisite of that, right? All right, and this is the one of the views of how we manage through the software, still have to manually extract the side, building side and building facade. And so still some quite editing, some automated, but not fully, and manual. It still can be quite intensive. Think about large-scale 3D modeling for a city. or even a nation, that's still a very unsustainable, very expensive proposition, I would think. Go next. Now, as you all know by now, the SuperMap, one of the things that SuperMap excels in is 3D, right? In addition to big data, remember that? Because our infrastructure is really big data ready. That explains why our software performance is better than our competition, way better than our competition, right? And 3D is another something we're very proud of, and we invested here. And this is the aerial photo overlaying on with the 3D vector data, so with which we can extract essentially building truly 3D vector GIS, which is something for quite significant event, we pulled that off, okay? It's integrated, yeah. Now here's another, I would say, a single set, multiple use, right? And this concept that I think I learned yesterday from the keynote plenary session. And here the 3D extracted the data, then you can use it as 2D, and then you can use it in different scenarios. Think about one data set, have multiple uses. This is one example of that. And we have that capacity built in to the system. And then there's another example of single set, multiple use cases. This is automatic generalization. So think about this particular scale, which 1 to 50, pretty large scale. And then we want to turn that into 1 to 2,000. And this, if you want to have one single data set to support this, and later you want to support this scale or this scale, you'd better store the highest resolution, which is over here, which allows you to, certainly this is not fully automatic. You need to set rules. So it's the rule setting allows you to make this transition so you can keep one level of data to be used by others. Many applications depends on its need. All right, then there's the role-based feature level editing. This is very important, even though I'm only touching this slightly, but think about the maintenance of data, the upkeeping of the data for sustainability. It's such a crucial part of our data ecosystem, correct? So incremental update, meaning no longer that you fly the same place once again, because you know the real world does not change at wholesale. Even in China, we don't change a city overnight, right? It's always incremental. So you want to have incremental change rather than reflight location, get everything together once. So incremental update with a transactional locking, which means multiple people can collaborate, work things happening, and also transaction tracking, meaning you can revoke, you can restore your transactions, go to previous versions as you wish, keeping historical context. The change, yeah. Multi-person collaborative, this is my favorite. And this is also what I think the holy grail of next GIS revolution. We're not quite there yet. Okay, now we come to the last part. From informatization to intelligent. And I actually stole quite a few photos from my friend Kevin. Where's Kevin? Okay, great. Don't tell him that I stole his slide. So glad he's not here. Yeah. So of course, you know why? Data explosion, size and format, increased demand of application with 3D thing. You know, it's funny talking about greedy human beings' greediness, right? When when we used to only have a paper map, we think 2D digital map is great. Then we have 2D grid map, we want the 3D vector map. Now we want what? We want the 3D scene to be realistic. You've seen quite a few examples of 3D scenes, right, being so realistic with reflections and everything. Those are powered by AI. And this is why I've put them all in this section. And again, why? Apart from greediness, we have 多, 快, 好, 省. Remember that? This is the third time it's showing up. It will be tested. Okay, here's one. Essentially from an aerial photo with a binary extraction, segmentation, we have this. Think about how powerful this is. Of course, you might say it might not be as accurate. Yes, if you need a survey level accuracy, you need like for legal purposes, it might not be. But as a large level for visualization purposes and for many other applications, this is adequate. How can you otherwise do it? So we have many, I'm pretty sure you've seen this already, right? And think about another one, because when you extract, it might not always be regular. Or the house usually is not like fuzzy, doesn't have fuzzy edge. So we have way to regulate, reduce. So look at the much sharper edge. All this also done by AI. So you don't have to do it manually, fix that, because no house will look like this. This looks like an organism, right? So this is being done. Is it going to be 100% foolproof? Probably not, but it's good enough, right? Okay, this is a point cloud extraction. Yes, even for LiDAR, we're able to extract an instant segment even by their position, what have you, and also identifying whether or not they have encroachment, whether it become a hazard because of the landscape and trees encroaching on the power line, which will cause fire, what have you. And I think some of the fire happened in LA, Los Angeles, or in California was because of power line. Yeah, we all know about the catastrophic fire happened a few years ago. That was caused by power line. So it's you can think about, you can just fly use drone and identify them, then you can dispatch maintenance people to fix them. Then, of course, from 2D modeling, how can we efficiently, faster to get this going? And again, this comes from Kevin, without his permission, perhaps. I think that's basically it. And we have a few more. I still more than just that one. And this one, you probably saw that. And AI-based extraction and AI-based real feature texture based upon the pattern, it will automatically vectorize it in the 3D space, right? Let's look at, again, based upon original image, and make a 3D facade like that, because it's, it's just using the pattern recognition and algorithm to do that. Think about how otherwise you could have spent significant time on that. And last is this image using many of the simulation technologies and creating certain ambient, certain environment, or the mood, set mood of this misty, perhaps slightly raining day, and just give you a dreamlike scenario. I think this is so fun. It really fills up our right brain, right? I hope it fills yours as well. I really enjoy this. So now let's, this is summary. Digital, informatized, and intelligent. And you have manual, trace, and efficient, highly automated. And now on the software tools, I would say SuperMap and EPS workstation in combination is really make this informatized being a very real reality. And our artificial intelligence framework or foundation, if you will, plus EPS to really making sure we have this modern 2D, 3D, real world type of experience. Now, it's not quite quiz time yet, don't worry. I'd like to talk about SuperMap contribution. You know, China, in just last 30, 35, perhaps 40 years, some people will say, it came a long way, as you have witnessed where China is at this moment. But 30, 40 years ago, we're way back. And we're very proud at SuperMap. We not only witnessed the rise of China's digital future or digital status as is today, we actually contributed to this process. And we believe that SuperMap, with us all work together, we can improve, enhance your digital future as well. This is the question. What was the 4-character phrase that showed up 3 times before? Anyone? My Chinese friends don't even try to steal the prize. Anyone? Yes, but that's not Chinese pronunciation. But that's great. That's great already. And here is 多快好省, writing from over here. And I know it's a challenge. For me, I spent 50 years learning English. I still consider myself still a student of English learning today. And it's a long journey. But, you know, there's one way you can cheat. Here's how you cheat. MFGC. So go MFGC. Thank you, everyone.